And let's continue with the next question in the balancing redox worksheets. We're going to look at question 3 now. I'm just going to start by reading the question. So the following outlines the oxidizing and reducing agents of some redox reactions as well as their conjugates. So when you see a sentence like this, the first thing you want to recognize is that the information given to you here is not every species present in the reaction. So you probably won't be able to balance this equation just by adding coefficients in front of the species. This is only the core species, so what undergoes oxidation and reduction, as well as the immediate products. You may have to add hydrogen ions or water or any other substances to balance everything. So you need to use this information to write balanced half equations for the oxidation and reduction processes, assuming acidic condition. And you then have to use that information to write the overall equation. Okay, the condition is acidic, which means that I can use cohes. And I'm just going to start with part A. So I'm going to find the oxidation numbers of everything first. So I could work out which one undergoes oxidation and which one undergoes reduction. Let me just change that to, okay. So copper is 0. This is -2 and +5. Hang on. I'm just trying to move here. My desk is really small. So +2 is copper 2 plus. This is -2, +2. So I've identified the oxidation number of everything. Copper goes from 0 to +2. So there is an increase in oxidation number. It has undergone oxidation. So this is your reducing agent. Reducing agent. The oxidizing agent is going to be the nitrogen in NO3 because it has a decrease in oxidation number from +5 to +2. So oxidizing agent, which means that my, let's start with oxidation. My oxidation process, before I start this, and I still need to move this writing part, I'm just going to quickly look to see whether I could split anything, but I don't think I can. Copper is a solid. NO3 minus is already an ion, so you can't break that into anything smaller. Copper 2 plus is already an ion, and NO is a covalent gas, so you definitely can't break it down into anything smaller. All right, so now we have oxidation, which is going to be copper solid going to copper 2 plus, and there is no, the key element, which is copper, is already balanced. There's no oxygen or hydrogen to be balanced, so I will just go straight to 2 electrons, which indicates that it's oxidation as electrons is lost. Now for the reduction, because this is under acidic condition, I can use cohes to balance. So I'm just going to go NO3 minus going to NO, and if we follow cohes, the key element in this case is nitrogen, and it's already balanced. You have 1 nitrogen on each side. I have 3 oxygen on the left and 1 on the right, so I need to add 2 H2O, which means I need to add 4 H plus in order to balance the hydrogen, hence acidic conditions. And now for the charge, I will have a total charge of +3 on this side and 0 here, so I need to add 3 electrons. Going to put in states, and just to check my half equation, I'm going to go back to the oxidation number change of nitrogen, which is supposed to go from +5 to +2, which does indicate a gaining of 3 electrons. Since you only have 1 nitrogen atom, 3 electrons should be gained here. So I think my reduction is correct. Once you have the oxidation and reduction, you should be able to write the overall equation by adding these two halves together. But before you do so, you need to make sure that the number of electrons are the same so that they cancel out when you add the two half equations together. So I need to find the lowest common multiple of 2 and 3. I will need to multiply the first half equation, the oxidation, by 3, so I would get 6 electrons, and we'll need to multiply the second, the reduction half equation, by 2, so I also get 6 electrons. And if you add them together, the electrons will disappear. You should never have electrons appearing in the overall equation anyway. So I will have 3 copper. You definitely can just write these half equations before you add them together, but I guess you really do want to be able to do them in one step, just to be able to do the addition in one step, because I don't think you're going to have that much time, and it does get better with practice, I think. So you have 3 copper 2 plus and 2 NO and 4 H2O liquid. So I like to do a last charge check before I'm finished. So the charge on this side is 6 plus, and on that side 6 plus. So obviously, if you have time, I would go and check that every single element is balanced. But if you press for time, then at least do a charge check, which is a lot easier to do. But I think all the elements should be balanced. So that's part A of question 3.